If we're evaluating g of -1 for this function, essentially this tells us that we're going to be taking and replacing our variable w with the value of -1. So essentially this notation says, hey, take this function that's named with the letter g, replace my variable with the value of -1, and see what result I get out. So if I replace w with -1, making sure to put it in parentheses when I plug it in, just like normal, then I'm going to end up with -1 squared is +1, plus 2 gets me 3. So g of -1 is equal to 3. Now, this isn't like multiplication. It's not g times -1. We're not solving for g. This notation just says, hey, I took this function, it's named with the letter g, I plugged in -1, I got out 3. So a relation is a pairing of input values with output values. A lot of times it can be represented as an ordered pair where you have your x value getting input and then your y value is where that gets sent as your output. Relations often have multiple ordered pairs, and notation-wise they should be contained and grouped with these squiggly braces. A relation has a domain, which is the set of all of your input values. Often we think of these as the x values in our ordered pair. It also has a range, which is the set of all of your output values or your y values. So our range on this one would be 2 and 3, domain would be 1 and 2. Functions we will get to in a minute. There are special kinds of relations called functions where no input value maps to more than one output value. So these have all sorts of nice properties that make them good mathematically to work with. So like, for example, this is a function because each individual input value, 1, 2, 3, only has a single output. Note that it's okay that both 2 and 3 get mapped to the output of 3. That's still a function. Something that is not a function would be, for example, if I take this list of ordered pairs in my relation up above and I add a new ordered pair. Let's say I add 3, 5. This is going to make it not be a function anymore because now I have one of my input values, 3, getting sent to 2 different output values. So I don't really know what to do if I start with the input value of 3. It's like conflicting directions. Should I end up as 3 as my output, or should I go to 5 as my output? Which makes all sorts of unfortunate mathematical contradictions happen, which is why we like functions. This relation is not a function because you have several points that have the same input value but different output values. Like this point 4, 2 and 4, -2 both have the same input value of 4 and get mapped to either -2 or +2. We're not really sure. So it is not a function, and there are many other points that do that same thing as well. Like I have 1, 1 and 1, -1. If you think about generalizing this, if you have any 2 points that share the same location on a vertical line, that indicates that you're not going to be looking at a function. So say that I draw this line over here. 2 points on that vertical line would both have the same x values of 6, but different y values of about -2.2 and about +2.2. So this is called the vertical line test. If you have any location on your relations graph where you can draw a vertical line and it intersects it twice, you have 2 points that share x values, so it is not going to be a function.